Okay, I couldn't figure out another way to kind of walk you through this worksheet other than kind of showing you the worksheet and walking you through it. So here we go. So the conservation of energy, and the question was about the spring stuff. So in the pre-lab, oh darn it. I'm skipping through everything here. Let's get up to lab number 10. Alright, so here we are in lab number 10. So in the pre-lab, what I was saying is that the work done by the spring is the area under the curve, which is 1/2 base times height. So we kind of talked about that. And there's another way to do that, which is to figure out the spring constant, and it's 1/2 kx squared, which winds up being the exact same answer, but base times height, when you graph it out, is kind of what we were talking about there. So I guess we didn't have questions about these in particular, I don't think. I think we're up to the questions about the data. So you collect the data, and so the average force of the spring times the stretch distance. Work equals force times distance. So for any individual data point, you can do the work for that individual data point. But then, this is where the question was coming in, when you graph that data, this isn't a linear force. If it was a linear force, it would just be a straight line over here, at 5 maybe, and the work equals force times distance. I could just do 5 times the distance of 0.5, and that would be the work. But this isn't a linear force, it's a variable force. So the force changes the greater the displacement. So that's where we do 1/2 base, that's the x-axis, so 0.05 meters, times height, the maximum, 5 newtons, and we get the 0.125 newtons. So we have the variables. If you want to calculate the work done in each segment and determine the total work done by adding all the segments, so each segment that we had on the data sheet up top, so 0.5 times 0.01. So going back up to the data, 0.5 times 0.01, 0.005 plus 0.015 plus 0.025 plus 0.035 plus 0.045. You add those all up, and we would get the 0.125 newtons, the same answer. So then experiment 2, I guess you'll have different types of balls that you might use, but you would figure out this average height, set of masses, potential energy, kinetic energy after the bounce. So I think your questions were all around the spring one and not these other ones, but just like that, the total energy should be the same. The potential energy decreases, the kinetic energy increases. Potential energy decreases while the kinetic energy increases. Yeah, I think that walks you through what your question was about, I think, with the 1/2 base times height, which is hard to explain in just an email. But if you can see the graph and know it's 1/2 base, the total x-axis, times the height, the y-axis maximum. So hopefully that helps.